Hello, today we will work out an example on the section 14.8 which is on Lagrange multipliers. I hope you read the introduction in the textbook, so I'll get to the problem immediately. The rest of the notes will be online. So let's do that. First, here in this example, the function f is given to be x squared plus 2y squared, and the constraint the g is given to be x squared plus y squared equals 1. So this is the equation of the circle with radius 1 unit centered at 1, 1, and the function f is given here. So we want to find the extreme values. That means we want to find the maximum or the minimum values of the function on the circle. That means there is like if you graph it, I'm not able to graph it here and show it to you, but if you graph it, there will be some amount of graph on the circle, inside the circle and outside the circle. So we want to find the maximum and minimum values of this function on the circle. We don't care about inside and outside the circle, but we are interested only in the maximum and the minimum values of the function on the circle. So using the method of Lagrange multipliers, let's find the gradient of f. For that you need fx, the partial derivative of f with respect to x. That's going to be 2x. Fy is going to be 4y. Then you find the gradient or the partial derivatives of g. So gx is going to be the derivative of x squared is 2x, derivative of y squared with respect to x is 0, derivative of 1 with respect to x is also 0, so you get gx equals 2x. So gy is going to be again 2y, the reason being the derivative of x squared with respect to y is 0, the derivative of y squared with respect to y is 2y using the power rule, and derivative of 1 with respect to y is also 0. So using the method of Lagrange multipliers, we know that the gradient of f is lambda times gradient of g. Make sure that the lambda is not equal to 0, because if lambda equals 0, then there is no point. That's fine. So in other, when you set them equal to 0, that means what do you get? You get like 2x and 4y equals lambda 2x and 2y. So that means if you set the components equal to one another, you get 2x equals lambda 2x, and you get 4y equals lambda 2y. So that means from here you subtract and you get 2x minus 2 lambda x equals 0. So that means factoring out 2x, you get 2x times 1 minus lambda equals 0, which means you get either x equals 0 or lambda equals 1. Okay. Similarly, that means what happens now. Let's look at this carefully. If if x is 0, let's write two cases. If x is 0 from here now, if x equals 0, then what happens? Substituting this inside, I'm not on the screen, let me get myself on the screen. Substitute if x equals 0, substituting x equals 0 here, you get 0 squared plus y squared equals 1. In other words, you get y squared equals 1. In other words, you get y equals plus minus 1. So if x is 0, then y is plus minus 1. That's one point that we have. Okay. Now if you set if you set lambda equals 1, then what happens? Let's observe that here. If lambda equals 1, so that means if lambda equals 1 here, what do you get? You get 4y minus equals 2y. Please don't cancel out y's and say 4 equals 2. That's wrong. So that means what you get? 4y minus 2y equals 0, and which means 2y equals 0, which means y equals 0. Okay. When y equals 0, now substituting y equals 0 in x squared plus y squared equals 1, we get x squared plus 0 equals 1. I hope I'm on the screen. So which means you get x squared equals 1, which means you get x equals plus minus 1. So that means y you get plus minus 1 and a 0. Okay, so you have 4 points. So the maximum and the minimum values can be at 0 plus minus 1 and plus minus 1 and a 0. So let's go ahead and evaluate where the maximum and the minimum values are. In other words, that means you want to find, how do you find what is the max? See, first of all, understand this. Here, what is your domain? On the circle they're saying. So your domain is the circle. Let me write it out here. Let me be on the screen here. Domain is circle. X squared plus y squared equals 1. It's a circle with radius 1 unit and center 0, 0. So that means the domain is closed and bounded. So that means you have a maximum and the minimum. You have absolute maximum actually and absolute minimum. Absolute minimum. Why? Because of the closed interval theorem that you learned it in the previous section and also in the calc 1, things like that. So you would have the maximum and minimums at any of these points. So to find the maximums and minimums, what you do is you substitute them back into the function. So if you want to find f01, like let's say 01, f01 would be what? 0 squared plus 2 times 1 squared, which is going to be 2. And 0, negative 1 means what? You want to find the function value at that. So that's going to be 0 squared plus 2 times negative 1 squared, which is going to be 2. And again, the maximum, the function value at 1, 0 would be f of 1, 0, which is going to be 1 squared plus 2 times 0 squared. So that's going to be 1. Negative 1, 0, the function value would be negative 1 and 0, which is going to be again negative 1 squared plus 2 times 0 squared, which is going to be 1. So you can see that the maximum values, maximum value of f is 2. And it occurs at 0 plus minus 1, and you can see that the minimum value of the function is 1, and it occurs at plus minus 1 and 0. Hope this is clear. I hope this is clear. That's how you find the maximum and minimum values using the Lagrange multipliers. Please understand this. In this problem, solving for lambda or solving for x and y happens to be easy, but it's not always that easy. Sometimes it gets difficult, and when it gets difficult, you really have to get creative or you have to be persistent. But on the test, I mean, it will be doable. It will be definitely doable. Okay, now let's do another problem here. Now find the extreme values of the function on the circle there. So what's the difference here? Here, like, I mean, you know, the function of g is x squared plus y squared is less than or equal to 1. That means here g is on the circle and also in the circle. I mean, in the previous problem, it was only on the circle. I mean, this is on the circle and not in the circle. I hope that makes sense. So this is not on the circle, but this one is on and in the circle. So by using that closed interval theorem or the extreme value theorem from the previous section, the maximum value, absolute max value and absolute minimum value occurs. I mean, it occurs at the boundary, or at the critical points. So critical points. Okay. Now this is very closely related to the previous problem. That's why I'm just doing a video on this. Now the boundary points are like, I mean, you got 0, plus minus 1, and plus minus 1 and a 0. So those are the boundary points. We don't know the critical points yet. So we need to find a critical point. And what is a critical point? Critical point is, this is a two-valued function. I mean, how do I say, function of two variables. So it's a function of two variables. So that means the critical point will happen when the partial derivatives is equal to 0 or partial derivatives does not exist. Okay, so let's find critical points now. First, find critical points. So you want to say, that means either fx is going to be, you know, that is 2x, and fy is going to be, you know, 4y. I mean, this is always defined. So set fx equals 0, so that means you set 2x equals 0, which means x equals 0. Then you have set fy equals 0, that means you want to set 4y equals 0. How many minutes is it? It's 10 minutes. Okay, so that means y equals 0. So that means the critical point here, so critical point is 0, 0. So the maximum, absolute maximum and the absolute minimum can occur at the boundary points, which from the previous problem is plus minus 1, 0, and 0 plus minus 1, or the critical point 0, 0. So which is where is the maximum and where is the minimum? Let's go ahead and plug in each of these into the function and find the absolute max and absolute min. You're not going to really apply the extreme valued theorem on this. I mean Lagrange multipliers. That means you're not going to set gradient of f equals lambda times gradient g of gradient g. All that you're not going to do here because you have already done in the previous problem. Okay. Now, what is that we're going to get? I mean, you know, boundary points here are, we found boundary points from the previous problem. From the previous problem, are plus minus 1, 0, and 0 plus minus 1. There are other boundary points too, but the extreme values will occur only at these boundary points. Remember that. So you want to find f of 1, 0. So that's going to be, we did that already. So 1 plus 0 is going to be 1. So then you get f of negative 1, 0 is going to be, substitute that negative, I mean, you know, negative 1 squared plus 0 squared is going to be 1. F of 0, negative 1 is going to be what? It is going to be 0 plus 2 times negative 1 squared. That's going to be 2. F of 0 and 1 is going to be 0 plus 2 times 1 squared, which is going to be 2. Then you get f of 0, 0 is going to be, this is the critical point we just found out. So when you plug it in, you get 0 plus 0, which is going to be 2. So you have, therefore the maximum value, I mean, you know, absolute max of the function of f is 2 at 0 plus minus 1. Then absolute min of the function f is 0 at 0, 0. Okay. That's how you find the maximum extreme values of the function using the Lagrange multipliers. I hope this helps you all, and I miss seeing you all in the class. And if you have any questions, let me know. Okay, let me set this properly. If you have any questions, let me know, and we'll go from there. Okay, have a nice day. Bye bye.